The inverter motherboards have two IGBT used in them. We will see what is the function of these two IGBT in inverter motherboards. We will also see the advantages of using two IGBT in inverter boards rather than using a single IGBT. Basically, the two IGBT are used to make the PFC or power factor correction better in the inverter boards, resulting in more efficiency. The power factor affects the voltages and the current. The current is more important. Due to the good power factor, the power loss in the electrical equipment decreases. Now, to make you understand the voltages and current, I will take an example of the human. As I myself am a human, suppose I am 220 volts. If I am just standing in a place, not doing any work, I am acting as standing voltages. If I want to pick up 100, 200, or 300 kilograms of weight, I should have the power, or that current to lift those weights. And should have the endurance to keep lifting them. If the voltages are present and the current is not, the system will not work. The PFC is used to stabilize the voltages with an efficient amount of current. Now, what is the waveform of an AC electric? This is the y-axis. And this is x-axis. We will consider y-axis as voltages. The x-axis will tell us the time when the AC electricity is flowing through a wire. Let me show you the direction of the AC current through the graph. First, it moves in forward bias. And after some nanoseconds, it moves in reverse direction. That is why it is called an alternating current. When it moves in the forward direction, the waveform will be made on the upper side of the graph, which is the positive waveform. And when it changes its direction, it starts from zero, and the waveform is made in the opposite direction, which is the negative side of the graph. The current is also flowing with the voltages. Now we will see the waveform of the current in this graph. I mistakenly had represented the current with C, as the current is actually represented with I. So remember this thing as we move further in the video. First, I will make its center point. And this is its center point. If the system is without PFC, the current will flow something like this in the system. The flow of the current will be something like this. It will move forward and will be zero. Then will move downward. This type of waveform will be made. The current in this graph suddenly increased and decreased for both the positive and the negative waveforms. To decrease this current spike, the PFC is used and the waveform of the current would flow with the wave of the voltages. Now let me show you the waveform of the current with PFC. Now, let me show you how the current will flow. The current flow started, it bent, then the same on the next end. Then it moves towards the negative point. The wave will be the same for the current on the negative side. The current without PFC looked like a spike, which was something like this. But now the current waveform is almost the same as the sinusoidal wave of the voltage. Now we understand the PFC installed with AC electricity and its waveform as well. But the AC electricity is converted to DC. Now, with the DC voltages, the DC current also flows. Now we will understand how the DC voltages work and, most importantly, how the PFC makes the DC current better. The wave of the voltages does not change much, but the waveform of the current changes drastically. I will make the Y and the X-axis to make the waveform. The full wave rectifier is used to convert AC to DC. A positive DC wave will be made. The direction of the DC current is in one direction, which is that it moves from positive to negative. Its direction does not change. A positive wave is made here. The next wave will also be made on the same axis of the graph, which will be the negative wave. The positive and negative will keep moving on the same axis. Now I will tell you the waveform of DC current without PFC. The current will flow, it will go to its peak point and then will drop from its peak point. The current reaches its peak point and then descends. This is the drawback without using PFC in DC circuits. It also increases power loss. Now I will see the current waveform with PFC in DC electricity. Let me show you how. The current flows and then descends. But now, the peak of the current is for more time than without the PFC. The time of the current descending has decreased. Now most of the power is used by your equipment, which runs your equipment more smoothly. In a very simple manner, I told you about the use of PFC with electricity. Most of you would know that most of the inverter circuits have one IGBT installed in them. But this video is about why two IGBT are used. If the one IGBT is able to make the circuit PFC perform well, and most of the system has one IGBT, then why do two IGBT is used in this circuit? Now, I will explain to you how well the circuit PFC performs by installing a single or a double IGBT. First of all, I will try to make you understand the waveform when one IGBT is used. I have made this diagram that has one IGBT used in it. It has an AC source. The AC source is connected to the bridge rectifier, where the AC supply is converted to DC. And 320 DC volts are present on this capacitor. Now one end is negative, and the other end is positive. The load in this circuit will not run until and unless this IGBT starts to work. Now how does this IGBT work? Let me explain to you. The PFC control IC turns on the IGBT. The electrons start to flow through the pins of these IGBT on the positive and negative sides of the circuits. Resistance starts to build over here in the IGBT. Due to this resistance, the reactor over here will be charged with current. At the same time, the PFC control IC will turn off the IGBT. As the load is also installed, and we need to run the load, the current from the reactor will flow forward. Always remember that the current in the reactor is stored in DC. But the reactor will discharge that current in AC. But as we don't need AC current in the DC circuit, we need to supply DC to the load. You always see that a diode is installed with the IGBT. This diode converts the AC output from the reactor to DC. And the DC current moves further towards the load. And the load starts to work. Now, we will see the graph of the current in the case of one IGBT. These lines represent DC volts. This IGBT will turn on, then will turn off, then on, and then off. And the cycle keeps continuing. The current will flow through the circuit. And the current will drop because the IGBT has turned off. The current will again flow through it and will drop again when the IGBT is turned off, and the cycle continues. The PFC has made the rise of the current a bit higher, which is beneficial. Now I will tell you about those circuits that have two IGBT installed in them. This circuit has the same AC source which is converted to DC with a rectifier. The difference in this circuit is that it has two reactors in it. The system will work almost the same as I told you on the circuit with one IGBT. The difference will be in the waveform of the current. And how will the PFC be boosted? The one IGBT is master, and the other is slave. The PFC control IC thinks this, and one by one turns the IGBT on and off. The name of one of the IGBT is Q1. And the other is Q2. When the Q1 is turned on, the Q2 will be turned off. The same when Q1 is turned off, the Q2 is turned on. It will be for all the cycles. What will the current wave look like in this circuit? Let's see that. I will draw the dotted line for the on position of the IGBT to make the current graph properly. This will be the wave of the current for the turned on IGBT. This is the point where the IGBT will turn off. The current will also stop flowing. The wave will keep moving in such a pattern. Now we will see the current graph for the Q2. It will be turned off when Q1 is turned on. The waveform of the current will descend down. The same waveform will continue. Now let me tell you what waveform on the graph will look like when both of these waves are merged together. The current in the circuit will stay for longer and the off time of the current will decrease. Hence the DC load will start work more efficiently. I hope you would have understood all the things I told you. Click on the left or right thumbnail to watch our next video. And subscribe. Thank you.